We added this is-off middleware on the server. Let's now protect all feed routes with it. Now this is super simple. We just copy that middleware and we add it to every route we have there as the first middleware before we do anything else, because if no token is there, we don't even need to continue with anything else. Every route should be protected here, so we simply add this to every single route. Now once you did add it to every route, you have to make sure that you pass the token on the front end. So this headers setup where you add this authorization header, this is something you now need to add in a couple of places in the front end. For example, our edit handlers there. There on the fetch request, we now should also add some headers, and the headers should contain our authorization token. If we scroll down further, we also got the lead post handler. Well, there, obviously, we also want to add some headers, and that one header we want to add is our authorization token. Of course, we can also fetch single posts. So in the single post JS file in the front-end code, where we fetch a single post, we also want to pass that second argument to fetch, add our headers, and there add the authorization header. Now we should be able to navigate around as long as we are authenticated, but I also want to lock down access to ensure that I can only edit and delete posts which I actually created. Now in the last lecture I deleted all posts, so let's make sure that we first of all connect posts and users when we create new posts. Just send the post, but I also want to set information about the creator. So here I'll add a creator key, and that will be, let's say, some object with an ID, underscore ID of creator underscore ID, and name, which is creator name. So I'm just passing this extra information with the response, and if I want to do that, I have to do it through a variable. So now posts get saved and get connected to users in both directions. Let's try that out. Let's save this code, go back to the front end, and there, let's create a new post. Good old duck again. Let's add a duck image. A duck, how lovely. Click accept here, and I get an error. Let's see what's going wrong. I do get back a response with a post, and the problem is that post holds my user data actually, which is a mistake on my side, of course. The post I'm sending back here is not the result. The result here is the user which I updated. Here, post should be the post model, the post object I created up there. So that's my mistake. I do create a post there, I stored it in a constant. I can reuse that constant down there to send data about that created post back to the client. So let me save that. Now, still what we'll see is in the database, if I go to the post collection, it was created though, because it only failed when it came to sending back the correct data. And there we see that it's also connected to a user, which ends with ABC. If we have a look at the users, this is this user. And there, in posts, we also find the ID of the post, which ends with 6E5. Yep, that is correct. So this worked. Now only a minor mistake here regarding the data I sent back. Let's simply give this a try again. Here's our post. Let's add a cup. Like this. Super hot. And now this works without an error. So now we are able to connect posts and users. Let's now take it a step further and make sure that editing and deleting is only possible for posts that belong to the currently logged in user. To check now, talking about deleting, there's one more thing we should do in case we do succeed. We should clear the relation of posts and users. If we refresh the posts collection, we only have one item there. But if I have a look at my users there, Now, the first user has a couple of posts and the second user has so too, because right now we have no logic to clear posts when I delete them, to clear relations. And we should of course do that. Now, how can we get rid of a relation? Well, we delete the post anyways, so there's nothing we need to do there, but on the user, we need to pull our reference. To do that, we should find the user after we deleted a post, let's say. So here, I'll find a user by ID, and I can use my request user ID here. And I will return that user object in there. Let's grab that code and add another then block where I will have that user mongoose model fetched from my database. Now in there, I will use my user model, and there the posts array, and then there is a pull method mongoose gives me. There I need to pass the ID of the post I want to remove. Now I deleted the post already here, but the post ID is still available of course. So I can pass post ID here. Now I can call save here to save that updated user and return that. Grab the response one more time and add another then block with a result of that operation. And here I'm done with clearing the relation. Now to see that in action, let me actually get rid of all users manually by using MongoDB Compass. Also get rid of all posts. And log out here. And let's create a brand new user because we cleared all users. Like this. Let's log in with that user. And that's it for this module. You learned that when moving from a classic Node application, which I don't mean in the sense of how you built it in the past, so simply just an application where you render the views in the server, that is a classic application because it is what we started with in this course. So if you move from such a Node application to a REST API, you learned that most of the server-side code does not change. You work with validation, files, and so on in exactly the same way as you did with, well, the classic approach. Only the request and response data changes because there you send JSON data, you don't render any views. You also got more HTTP methods available, which you can use to, well, construct your endpoints, your API endpoints. And the most important takeaway is that the REST API server does not care about the client. The requests are handled in isolation, so every request is treated as if it would arrive for the first time. So we don't use sessions. The server, the REST API, does not store any sessions. It does not store any client data. Now that has important implications for authentication. Due to no sessions being used, the authentication works differently. Each request needs to be able to send some piece of data that proves that the request is authenticated. And that is this JSON Web Token, which we generated and worked with in this module. It's a common way of storing some authentication information in a token, a piece of data, which you send to the client, which you store on the client, and which then gets attached to every outgoing request to a protected resource. JSON Web Tokens are signed by the server, and only the server can validate them by using a private key, which is only known to the server. Hence, you can't fake or manipulate tokens on the client. And that's it for this module. We now had a detailed look at building REST APIs, a common form of Node application which you need in a lot of scenarios, and now you have already a very broad tool set which allows you to build extremely versatile and powerful Node applications. We're still not done with the course though, there's more to come. You learned about a brand new type of backend application you can build with Node.js, a RESTful API. And you'll learn that it's not that far off from the server-side rendered Node application we built before. The only major difference is how you handle request and response data. You send JSON data. Now, with that out of the way, I want to dive into something totally different, which is applicable to any Node application, not just to RESTful APIs. I want to dive into the async await keyword, which is a relatively new JavaScript language feature, which you can use, again, in any place in your Node.js code. This does not have to be used in a RESTful API. You can or can not use it anywhere. And I will explain what's up with these two keywords, how you use them, and why you would use them. So what is async await all about? Async and await are two keywords which are part of the core JavaScript language. They're not an exclusive part of the Node.js runtime. They're also available in modern browsers or in front-end projects. They're not part of Node.js, but you can use them in Node.js projects. The question, of course, is what do these two keywords do? Async and await allows you to write asynchronous requests. So requests where you have some operation that takes a little while and comes back later in a synchronous way. And you see there's an asterisk after synchronous way because async and await allows you to write asynchronous statements in a way that looks synchronous, but it still is an asynchronous request. Now, this is of course very abstract. So let's simply dive into our existing Node.js code and let me show you which parts of it you could change to use async and await. And then it will become very clear what it does. I'm back in my Node.js backend application here, and let me point out that, as I mentioned, you could also use async await in the React application. But this is no React course, so I will leave this code untouched and I will go back to my Node application. Now, how can we use async and await? Well, if you go into your feed controller, you see that there we have an asynchronous operation, post find. How can you see or how can you identify asynchronous operations? Well, for example, when you're using promises. Promises are a typical construct that help you deal with asynchronous code because promises work like that. Post find gets executed and count documents also gets executed immediately, but then this actually, count documents, returns a promise or a promise-like object, and you then use then to define a function that should be executed once this operation here is done. And since we access the database here, this typically takes a bit longer. We're talking about milliseconds here, but still, it doesn't happen instantly. On the opposite, this line and this line get executed after each other instantly. This operation does essentially not take any time at all. It's so fast, JavaScript can wait for it to complete and move on to the next step right away. Here, it will not wait for that to complete, and that is why after this statement, JavaScript would actually move on with the next statement in line. So if we had another statement on the same level as post find, we would continue with that. Now, in this case, we got none, but if we would have some code there, like a console log or anything, this would execute right away, probably, or very likely, before this or this code or this code was executed. And the reason for that is that with then, we define code snippets or we define functions that should run in the future once this longer taking asynchronous operation is done. And it's called asynchronous because it doesn't happen instantly, but it takes a little while. Callbacks, which we used earlier in the course, are another way of working with asynchronous code. So here too, for count documents, you could actually, and you see that here in the documentation that pops up, you could define a callback function. So here you could define a function that gets executed once it's done instead of then. And we don't use callbacks because in there we would use that code. And then we would need a callback here in the find function, and we would nest all these callbacks, leading to very unreadable code. That is why you often prefer promises, even though you could do it with callbacks, because there you have one then block after each other and it's very readable. Still, it can get more readable with async and await, and that is what I want to show you in the next lecture. So now that we had a brief look at how asynchronous code can be identified and what is important about asynchronous code, and that you can use callbacks and promises to handle asynchronous code, now that we learned all that, let me introduce you to async await. To use that, you first of all have to prepend the async keyword in front of a function, like this arrow function here, so this function, where you plan to use the await keyword. So where you want to use these two keywords. They always are used together. Async in front of the function, and then you can tweak this syntax. You can write this syntax almost as if it would run synchronously. You can get your count, a new constant or a variable you create, by awaiting post find count documents. And then you would get rid of this then block here. You would instead continue here, or you directly store your total items here to be precise. You can get rid of this line now, and you get rid of this return statement. And instead, you continue with the next line, post find limit. This gives you back a list of posts, so what you currently have in that then block. And you again write it like this, posts await post find. And then this whole statement that in the end would be followed by a then block. You now get rid of the then block like this. Let's comment out catch, because that is something we'll care about in a second. And now if I reformat this, this is our adjusted code. This is using async await. And this now looks like the normal JavaScript code we write, but behind the scenes, async await takes your code and transforms it into the old then-like structure we used. So it uses then behind the scenes, we just can't see it, and we have this more convenient way of writing our asynchronous code. Now, I haven't used this in this course thus far, because I think that if you're relatively new to JavaScript or Node, this can quickly lead you to think that this works just like the other code lines. And indeed it doesn't. Always keep in mind, await just does some behind-the-scenes transformation of your code. It takes your code and adds then after it, gets the result of that operation, and then stores it in total items, and then moves on to the next line, executes that inside of the then block it creates here implicitly. So basically the exact same code we had before. This is done by async await behind the scenes. But if you understand this, then this can be a syntax you might prefer. You don't have to. You can absolutely use the other one with then and catch, but you might prefer this one. Now, back to catching. How do we handle errors now? Well, since this now runs almost like asynchronous code, we use try and catch. So we try something, we try some code, this code here to be precise, and we then catch an error like this, which we then handle in there with the code we previously had inside of catch, like this. And therefore, you still have to next an error here, because keep in mind, behind the scenes, this gets converted to then and catch as we used it before. But now with that, we have transformed this first snippet where we used promises to async await. And we can see that if I now save that and I go back to my running application, let me quickly log in and open the developer tools to see if we get any errors. And I currently got no posts, so I'll quickly create one. Test post. We'll take that duck again. This is just a test. Let me hit accept here. And this looks good. Now if I refresh, we definitely fetch the posts, and this still works. So all that code still works. We also got no error here on the backend, and now we transformed this to async await. Now Max from the future here. In the last lecture, we added async await and I explained all about it. Now what I explained there is all correct, but there is one important addition I want to make here. Starting with version 14.3, which when I recorded this video was just released, starting with that version of Node.js, you can actually use the await keyword also outside of asynchronous function. This is a feature called top level await. You would be able to await a promise which you have here in the top level of your script, so which is not inside of a function. You can now also use await here. Previously, this was not really possible. You always needed an async function around await. Now you can use await on the top level. If you are using it inside of a function, as we are doing it here though, you still should add async. So that hasn't changed. It's just this extra addition that you could now also use await on the top level. And I just found this important to mention because it is part of Node.js and it is related to async await. Or to just await then, I guess. So we are using async await everywhere now. And there's one important thing I want to highlight here. For all these mongoose operations, which is the primary thing where you use async await, you have to understand that mongoose, actually with operations like count documents or find, does not return a real promise, but a promise-like object, where you can use then and catch and also async await. That is supported by mongoose, even though behind the scenes it's not a real promise. Doesn't matter too much for you, to be honest, because you use async and await in exactly the same way you would use it on a real promise, but I also don't want to hide that fact from you. You could use a real promise by chaining exec after all these mongoose operations, so after find, after count documents. If you do that, then you get back a real promise. We don't really need that here because, well, that promise-like object behaves in exactly the way we want. You do have a real promise with the bcrypt library though. When we hash our password, here we get a real promise, and as you can see, well, you see nothing. You see no difference in the way we use await, and you also had no difference you previously used then and catch. So that is what I mean. You don't need to care too much about that. I still did want to mention it. More importantly, I want you to take away that async await is a nice alternative to using then and catch. It's not better, it's not faster. Behind the scenes, it's basically the same code. It can be more readable to you, but you must never forget that this still are asynchronous steps. The JavaScript code execution behavior doesn't change because of that. It does not block execution, it simply wraps all the code after an await statement in the then block you would have to write otherwise. So this runs inside of the implicit then block this statement creates. This is how you have to think about that. So never forget that these are asynchronous operations, because that is really important to understand. And you can absolutely go with the then and catch block we used before, so with the old promise style if you prefer that. I like it for teaching because it's clearer that we have some operation to wait for and that the line after that would execute first. Here this is less clear, but if you are aware of how async code works, this can simply be a nicer syntax to look at, and it's up to you which syntax you'll use. For the rest of the course, I'll write new promises, or I'll stick to that async and await syntax for my Node application. For the React application,
I'll leave the code as it is with then and catch. You could use async and await there too, but again, this is no React course, so I will leave it there as it is. For Node, we'll go with async await.